Thank you for joining me on this light talk of refactoring. This is a very large topic. We're going to cover a very thin slice, and I want to go over a couple concepts of it with you, and to explain why changing code without changing the behavior is beneficial to the code base and the user. So, some things that I want to go over. Table of contents, obviously, just a quick overview. What is refactoring? Why refactoring? The role of testing, when you should not. Quick wins, the rule of three. So, what is refactoring? Making small incremental changes. So, introduction, you know, when facing the challenges of maintaining an existing code that's difficult to understand and modify, we have some tools under our belt, and refactoring is one of those tools. There's other tools that you can use. Some of those tools will come inside of the IDE itself. Maybe it might be pulling methods, renaming variables, where the system will do it itself, and you're not manually rewriting all of those variable names. So it reduces the amount of error, and sometimes we can make these changes without even writing any test because the IDEs have become so advanced. Um, what is the purpose of, improving in the designing of existing code without changing its functionality? This presentation will introduce you to a few key concepts and strategies. Hopefully, in this presentation, you'll learn what is legacy code and why is it challenging, some fundamental principles of working with legacy code safely and effectively, how to identify some common issues in legacy code, practical techniques, understanding for testing and refactoring legacy code. And by the end of this presentation, hopefully you will be equipped with a few more tools and knowledge to conquer the challenges of legacy code. So, as we see up here, code without tests is bad code. We can all read, but just in case, I'll read it for you. It does not matter how well it is written. It doesn't matter how pretty or object oriented or well encapsulated it is. With tests, we can change the behavior of our code quickly and verifiably. Without them, we really don't know if our code is getting better or worse. And that's Michael C. Feathers. He is a very big name in the software space and in the testing space. So going on to the next slide. So right here, one of our first concepts is going to be seams. Seams are places where you can change the code without affecting other parts of the code. Dependencies, this is more of a conversation about coupling and tight coupling. Move that out the way. So, change points, another word I would use for seams in my mind's eye is identifying seams is crucial for minimizing the risk of regressions when modifying legacy code. And our goal with dependencies is to break them. So, breaking these dependencies can often involve isolating specific functionalities and abstractions behind them. So, basically, introducing interfaces in front of these dependencies so we don't use a class directly. So, that's one good aspect. Um, Test points. These are points in the code where tests can be easily written and executed. These are like very small, quick wins. We always want to go for that. And conditional code is this is code that may have unnecessary conditional branches. You'll always have conditional branches. Um, just one of those things you can't typically avoid. So why refactor if the code is already working? Like it's doing what it needs to do. Let's just leave it alone. Well, I would say that it's important to refactor when you're able to, and eventually make this a skill that's just a part of your work process. Because when you're adding new features, the last thing you want is something in the past to slow you down. And when you're refactoring, breaking dependencies, adding tests, you're going to get that feedback a whole lot faster. So you can build things quicker. It just feels as if you're going slower. It's oxymoronic, but it really does work. So first thing is you cannot refactor without tests. Without code coverage, you just don't know if you're breaking things or not. And it's very important to not make the code worse when you're trying to refactor. So, um, good thing that I wanted to cover real quick is improve maintainability. Reduce complexity. Refactoring eliminates code smells like duplication, long methods, complex conditionals, making code easier to understand and modify. Increase readability, well structured code with clear naming conventions and proper indentation improves readability for developers working on the code base. Enhance testability. Refactoring code is more modular and easier and cleaner boundaries, making it easier to write effective unit tests, integration tests. E to E tests, different conversation, but those do exist to ensure code quality. Simplify bug fixing by addressing underlying design issues. Refactoring can make bug fixing faster and less error prone. Reduce technical debt. Over time, unaddressed issues in the code base accumulate technical debt, making it more difficult to maintain and extend. Refactoring helps reduce technical debt and assure long term sustainability. The role of testing: fast fail, fast feedback. This could be a talk of its own, testing in general, but unit test as an automated test that isolates and verifies the functionality of a single unit of code. This unit could be a function, a method, a class, a module. They're critical in refactoring because they provide a safety net that ensures that the changes made do not affect behaviors of these units. By running unit tests before and after refactoring, you as a developer can quickly identify any regressions and fix them properly. So when you're refactoring, you're going to break stuff. And the first thing you're going to want is information back, as if what you just changed broke something. Integration tests, or another great test, characterization tests. Integration tests are an automated test that verifies the interaction and collaboration between multiple units of code, and they are practically important when they're practically important when refactoring involves modifying interfaces, interactions between different components. By running integration tests, we can ensure that changes made do not break existing and other systems functionality. We always want things to work exactly the way that we started with. It's only better on the code side of things so we can develop more product on the end game. So there is that. So right here we talk about characterization tests. Um, Sometimes you're going to be in a situation where you might not be able to write a test that would lean itself in the category of an integration test. So characterization test, or also known as gold master test, are automated tests designed to capture the actual behavior of an existing piece of software. They don't check the expected behavior, but rather document and verify the current and often untested, undocumented functional outputs, including edge cases and unexpected scenarios. So this is a way to just make sure that what you have is what you get after you refactor. So once again, like I said, this was going to be a short introduction. We're going to move to the next section. This section is going to be, we're going to look at a very short demo of a refactor process. So here, we're going to look at this file here has um, some issues, I would say, for the least. By just looking at it right here, this is a hard-coded datetime. That's going to be very hard to test. New is glue. So right here, we have a client repository that we're just going to new up and just use right here. And if we scroll down just a little bit more, we can see that we're using user data access, add user. That just seems like a static class that's being called. We have some more new right here that's glue. So there's some things here that if we were to just try to write a singular unit test, this would this would just be an issue. This would just fail and start to break down. So one of the first things we would want to do is cleaning it up. So this you can't see, but here I started moving things into folders. And then secondly, I started working on the datetime. So right here, we're going to start introducing interfaces. This interface is now mockable. So when we decide to create a unit test for this whole method, now we can inject our own datetime. A great kata to understand what's going on, because like I said, testing is its own thing, is the file logger kata. If you can Google the file logger kata, you will start to understand how you can slip interfaces into seams. It's a great kata to practice if you're not familiar with coding to interfaces. So right here, as you can kind of see, I'll go back just in case. We had this nude up. We don't want that, because when you're trying to do a unit test, this is gonna, even if we were trying to run the application directly, there's no need to run and create a new repository every time this method is called. But especially in a unit test, this will cause issues because this is going to call services that we don't want to call during a unit test. So now that we're using another repository, this is now mockable, which means we can tell the unit test what it should see. So if we scroll back up, you'll see that we created another interface. Scrolling down here, we're getting rid of that new. Everywhere you saw new, we don't want to use new. New is glue, and that's a great phrase to remember. So with us removing that, once again, now we have another spot in this test that's mockable. If we go over, we'll see how at the bottom we got rid of the static class that was calling its own add user method. And right here, we're just creating a constructor so we can actually inject these interfaces into the software. And right here, we're actually not changing anything. So the code itself has not really changed, but a lot has changed around it. So this effectively is the same code base, but now it's cleaner. And why is it cleaner? Because if we come over here and we zoom out just a little bit, now we can start to create tests. All of those places we created interfaces for, we can now start to create substitutes or mocks, depending on how you would want to go about that. And over here, because our goal is not to always change everything in the application, sometimes we can't change anything in other places. So we're actually kind of limited, which forces us to be a little creative. Um, Here, this is just showing us how we're using that new constructor that uses the old constructor, and we're creating a very simple test. All we're doing is coming here and creating that client. We're using the builder pattern, which, depending on who you are and what you like to do, you could use a different tool, maybe auto factor or something like that. We are using C sharp in this presentation, but I prefer the builder pattern. I don't think there's a wrong way. I just like the control the builder pattern gives me. A quick overview of the builder pattern is you're coming here and you're using the this keyword, and you're just stringing along each value that you want to add to the object. And at the end of the day, you just return that object because each one has just passed this forward. So if we come back to our unit test, you can see how we're using the builder pattern. And with test values is something that I've gained from a different person. It's actually not my idea, but over here you can kind of see we just set uh, default values. So ID equals 1, client name equals client test. And our goal here was just to make this class testable. So there's a lot more work to be done in this kata. I recommend just doing katas in general to help you nail home the skills of learning how to refactor. But this was a great quick overview of showing you seams, how to replace things with interfaces, and not just things. Things is a bad phrase, but sections that had new as glue, sections that were using static methods, those types of things will destroy a unit test. So learning how to replace those things with interfaces that we can mock is the best way to go. Two books that I recommend before we get out of here. I recommend the book Refactor, and I also recommend the book Working Effectively with Legacy Code. And if you're not familiar with testing, there is a few testing books out there. The X Unit book is a really, really big book. And there's one other book by Vlad, Unit Testing. It has a very long name and I can't remember it right now. So I'll try to make sure to put that in the show notes in the text file so you can have access to that. And thank you for coming to my quick talk. Really appreciate it.